All right. For the some of the problems, for the rest of the problems for section 2.4 or the infinite limit, we call infinite limit. Okay, infinite limit. That means either y approaches infinity or y approaches negative infinity. As x approaches a. Okay, and that point A will give you the vertical line, which is called the vertical asymptote. X equals A asymptote. And what we did last time, we looked at more algebraic function, like you have x, you have x squared, you have the quantity, you have the plus minus sign. Now, we will look at the trig function and consider the same way. Okay, for the function cosecant theta, we look for the limit of the cosecant as theta approaches 0 positive. 0 positive, that means theta is a little bit greater than 0. The tip and technique for this one is think about the identity that is equivalent to cosecant of theta. Anyone recall another way to rewrite the cosecant of theta? Or another trig function that we can use as a substitution of the cosecant theta?
Is it 1/. Sine?
Yes, it's 1 over sine. Thank you, Jonas. Is the reciprocal of sine, okay, sine theta. Now, when you see as a fraction, the thing is the denominator cannot be 0, correct? If we do the direct substitution, yes, Jonas? You are muted. Do you have question? Are we good? Okay. Okay. Think about the denominator that cannot be 0. If you use a direct substitution, you treat the theta as 0. Psi as 0 gonna be 0. It's not gonna happen. So we have to do something to consider this by analyzing it, like what we did last time. What the graph of the sine looks like. Do you recall the graph of the sine? At the 0, psi is 0. We know that, right? And then it's like it behaves like the wave graph, if you recall the wave graph. At the point 0 here, we look for the graph, the function approaching to whatever point as theta approaches 0 from positive direction. So if we move along the graph, it's coming toward to 0, even though we look at the right side, right? So same way that what we analyzed last section, the numerator stay as 1. The denominator is going to be very small. See, the graph is approaching to the value 0. Going to be what positive? What's the sign? The sign going to be plus sign, right? Going to be positive inside because when you look at the graph, it's the positive side of the graph. So going to be plus sign and very small, very small. With this way, 1 divided by small number, gonna get the quantity that very, very large, but plus sign. Therefore, the limit of the cosecant theta is positive infinity. Okay, use the graph to help you put pieces together. And then similar way, the limit theta approaches pi over 2 minus psi. The tangent theta. Well, if you recall the graph with tangent, that's great. If you don't recall, what can we do to find or to evaluate the limit of the theta of the tangent theta as theta approaches pi over 2 from negative side? My first question, do you recall the graph of tangent? Anyone recall? Okay, let's see. If you have the graphing calculator, you can plot the graph and to see what the graph looks like. This is a graph, one piece of the tangent, another piece, and many, many pieces, many pieces. Okay. The vertical lines, you have multiple vertical lines for the tangent. which is negative pi over 2 here, pi over 2. So if you need more detail, go to section 1.4 for the review of the trig function and the graph for the trig function. If we know the graph, we can use the graph as what we did in part A to find the limit of the tangent theta. As theta approaches pi over 2, where's pi over 2? Pi over 2 right here, coming from the left side, because the negative side here, okay, coming from the left, what the graph going to, what the behavior of the function? Going all the way up. Therefore, this is approaching positive infinity. Okay, use the graph. And don't feel like you are intimidated by the function, because the trig might not be your favorite function to work on, but use the same way that what you did for the other kind of function. You're gonna get this. You can use the same technique to find the value of different kind of functions. Another way that you can think of, you could not recognize the graph, or you don't have the graphing calculator handy. Jonas, do you have questions?
No, I'm good.
Okay. Like on my screen, like looks like you are going to say something. So yeah. All right. All right. Another way that you can think of would be writing the tangent theta as sine theta over cosine theta. Okay. And with what we did in part A, we have to be focused on the denominator, because we cannot divide by the 0. Again, if you do the direct substitution, the cosine of pi over 2 is 0. Direct substitute doesn't work. We're going to analyze it similar way. For the sine theta, sine at pi over 2 is always 1. And for the cosine, look at the graph of the cosine. Cosine at 0 is 1. And the graph going in the wave behavior similar to the sine, but it's just like starting at the different point. And at pi over 2, negative side, the graph coming toward to the value 0, but the graph is positive. That means it's going to be positive inside and very, very small. And that returns the same result as the tangent theta approaches infinity. Okay, so I was showing you that there are multiple ways to analyze it, especially when you work with the trig functions. Trig has many identities that you can use to represent the same thing. So that's another thing that's very important. If you recall the trig identity, gonna help you work on the problem in the less complicated